Assalamualaikum warahmatullahi wabarakatuh. And hi everyone, my name is Norfazrin Yasmin Binti Faizal.
My name is Emir Ashvin bin Badul Shahly.
And my name is Cik Mohamad Yusuf Firdaus bin Zulkifli.
So, my teams will present about our project ECS246, which is Civil Engineering Material Sustainable Product. First, for presentation contents, for partial replacement of cement in concrete, my team have choose 3 types of replacement of cement in concrete. Okay, first, palm oil full ash, second, sugarcane ash, third, rice husk ash. Okay, first, for palm oil full ash, which is known as POFA. For introduction, POFA is an agro waste generated in palm oil industry. It is obtained from the combustion of palm fruit residues of oil palm tree. Generally, the wastage of palm oil from palm oil industry was increasing eventually. It is become a major problem to palm oil power plants because this waste is not reused and recycled in any words. Therefore, POFA, whose chemical composition contains a large amount of silica that can be used in cement replacement. Okay, next is methods of palm oil full ash. First is material use, which is pollen cement of grade 53, coarse aggregate, fine aggregate, super platinum, master geranium, SKY 8233, palm oil full ash, and water. For methodology, first physical and chemical properties, mix proportioning, and test specimens. And for the result, compressive strength, flexural strength, strength, tensile strength. Okay, next, methodology. First is for physical and chemical properties. So we can see below for the table of chemical composition of POFA. We can see they have silica, iron, potassium, sodium, magnesium, calcium, aluminium, and sulfur, and each percentage in POFA. So next is properties of cement. So in the table, we can see the property and the test result of POFA. We can see the result of specific gravity, which is 3.15, initial setting time 90 minutes, consistency is 31%, compressive strength 53 Newton per millimeter square, and fineness is 2%. And then for next is properties of aggregate. For fine aggregates, the specific gravity of POFA is 2.66, fineness modulus is 2.5. For coarse aggregate, specific gravity is 2.7 and water absorption is 1%. Okay, next is mixed proportioning. The proportioning of ingredients of concrete depends upon factors like quality and quantity of cement, water, and aggregate, batching, mixing, placing, compaction, and curing. The target of compressive strength was 40 MPa, and they have prepared 5 samples, and which one is the control mix of 0% of POFA. And then cement was replaced by 5%, 10%, 15%, 20% of POFA. And we can see the table below, which is mixed design for 1 and square concrete. For cements, water, fine aggregate, coarse aggregate, and super platinum. Okay, next is test specimen. Compressive tests were done on cubes for curing periods of 7 days and 28 days. The flexural compressive strength of concrete was determined by beams of curing period of 28 days and 56 days. And then the split tensile strength is evaluated by cylinders of 150 mm diameter and 300 mm length for curing periods of 7 days and 28 days. 3 specimens were tested of each testing case. Okay, next is result for first compressive strength, which is we can see at the table below. For the cement replacement and the control is 0%, and the replacement 5%, 10%, 15%, and 20% of POFA, and the result of compressive strength for 7 days and 28 days. And from the graph that have shown, which is the maximum value for compressive strength is obtained for 10% replacement. Beyond this optimum point, compressive strength begin to decrease. Okay, next is the result for flexural strength. So based on the table that have shown, which is the result for each replacement and also the control ones for flexural strength in 28 days and also for 56 days. And based on the graph they have shown, which is the evidence that flexural strength increase with increase in percentage of POFA, and the maximum strength is obtained for 10% replacement. Okay, last for the result for split tensile strength for POFA, which is same at the table below of each result for replacement and the control ones for the result split tensile strength in 7 days and 28 days. And based on the graph I've shown, the result show that the maximum value of tensile strength is obtained for 10% replacement of OFA. So, based on the result of each test, which is compressive strength test, flexural strength test, and split tensile strength, the percentage of the replacement that have shown the higher result was 10% of replacement of OFA.
Sugarcane is the main food crop in tropical and subtropical countries like in Malaysia. It is a major resource of sugar production. Bagasse is the waste created after juice extraction from the sugarcane. The sugarcane bagasse ash, SCBA, is obtained through the control of burning of sugarcane bagasse. SCB creates the environmental nuisance due to the direct disposal on the open land. To reduce the environment burden, the usage of the waste material in concrete is very significant. From the sugar industry itself, the waste material are the sugarcane bagasse ash. It is a potential to utilize it into concrete with cement replacement, as we have a lot of waste products here in Malaysia. Cement is the most widely consumable material in the infrastructure development works. It is considered as a durable material of construction. However, the environmental issue of cement has become a rising concern due to more heat was being blasted just to get the raw material of cement. Considering the fact, one of the effective ways to reduce the environmental impact is to mineralize mixtures such as the partial cement replacement in concrete, which will have the possible to lower the cost, energy usage and also waste emission. Method of sugarcane bagasse ash, SCBA. The material used in this test are the ordinary Portland cement, coarse aggregate, fine aggregate, sugarcane bagasse ash and water. For the methodology, we have done the physical and chemical properties and test the specimen. We have done the slump test and also compressive strength of concrete. So here we can see the chemical composition of SCBA. So we have done a total of 36 concrete specimen, and the size of each specimen was taken about 150mm in diameter and 300mm in length for the cylindrical shape. The concrete mix were prepared and the concrete cylinder were kept for curing for 7 days, 14 days and also 28 days. The slump test was being done for each grade for the non-disturbed concrete and also the replace of SCBA. After the completion of the required curing period, each of the specimen was checked for the compressive strength in the compressive strength machine.
So this is the result of SCBA in concrete. So for the slump test, the range of slump test was targeted between 25mm to 75mm, but the slump test was fall in the category of low and medium degree of workability. Therefore, the usage of super plasticizer is not essential in this case. This is the result of compressive strength of the concrete grade M20. As we can see here, after the replacement of 5% of SCBA, after 28 days, the compressive strength was 29.92 Nm². And for the M15 concrete grade, after the replacement of 5% of SCBA, after 28 days, the compressive strength was 27.20 Nm².
I will explain about the study of the use of sustainable materials, namely rice husk ash, to replace a few percentage of cement content in concrete production. Rice husk ash, a more modern pozzolan that has been studied from a variety of perspectives, has contributed significantly to durability, permeability, and chloride ion penetration. According to the research, as the amount of RHA replacement increase, compressive strength decrease. For this study, a few material has been used. First, cement. Second, microsilica. Third, rice husk ash. Fourth, gravel. Fifth, plasticizers. And the last is sand. For the methodology, different percentage replacement RHA mixed proportioning was made for the test specimen. The result come from 4 tests, which is compressive strength test, tensile strength test, short-term water absorption test, and rapid chloride permeability test. 8 cube specimen with 100mm every side was made for 3 tests, which is to determine compressive strength, water absorption value, and rapid chloride ion penetration. 4 tests has been done. The first is compressive strength. Before test has been done, the specimen will experience water curing for 7 and 28 days. 2 types of tensile strength test has been done. First direct and the second is indirect. Short-term water absorption test is for defined as residual water remain in concrete interface, which make it more vulnerable or durable. The specimen will experience water curing for 72 hours before drying and placed in cold water for 1 hour. Rapid chloride permeability test used to evaluate concrete penetration under chloride attacks corresponding to standard of ASTM C1202. In rapid chloride permeability test, total charge of about 60 volt passed on to a saturated specimen during 6 hours period is calculated.
From the result compressive strength test, we get RHA 20% replacement percentage give the highest of compressive strength test for 7 days and 28 days. The second is RHA 15% percentage replacement and the others above than control mixture. The dry density of specimen decreased with the increase of replacement percentage. For the tensile stress test, RHA 20% of replacement percentage give the highest value. Based data from tensile strength test, modulus elasticity was calculated. The result showed that RHA 20% percentage of replacement give the highest value. For short-term water absorption test, the data decreased with the increasing of value replacement percentage. The highest value is control mixture and the lowest value is RHA 25 percentage of replacement. For the rapid chloride permeability test, the data also decreased with the increase of value replacement percentage. The highest is control mixture and the lowest is RHA 25% of percentage replacement. After several tests conducted on these three sustainable materials, we found each materials have optimum percentage replacement that can give benefits to the concrete. For palm oil full ash, the optimal replacement percentage is 10% of the cement. For sugarcane, the optimal replacement is only 5% of the cement. And lastly, for the rice husk ash, the optimum replacement percentage is 20% to 25%.
The research of SCBA was a bit unclear as the research only includes some tests and also compressive strength and not the other tests. But again, this study will contribute to the development of future sustainable product as we can lower the rate of throwing sustainable product and increase the usage of them. We can lower the production of cement and indirectly we can protect our environment from being destroyed.
So that's all from us. Thank you.